This new year, we are going to start another exciting series called the Enough of the Gyan. Let's directly jump to the class where we will learn about C programming, data types, variables, etc., and a lot of program. Let's jump. Thank you. Hello friends, welcome back to another exciting episodes of Career Advice. I wish a very happy, healthy, prosperous and exciting new year to all of you watching over there. So let me know what all of your resolutions are for this new year, and I'm going to tell you what my resolution is for this new year. So in this new year, we are going to start another exciting series called the Unicorn Journey. So in this series, we are going to talk you about the different founders from the bootstrap till they attack to the unicorn status. Trust me, this is going to be a very exciting program where we will not talk about any kind of controversies which we really don't want. Rather, we will learn the founders' journey from grass level to their achievement level. So let me know in the comment section how excited you are for this series. And for today, enough of the Gyan. Let's directly jump to the class where we will learn about C programming, data types, variables, etc., and a lot of program. Let's jump. Thank you.
Okay, so last session we discussed regarding the C structure, introduction of the C, and how we can write the C program. Now today we'll go into the in-depth what are the data types in C. So if we are talking about the data types in C, mostly these are the containers in which we store the data. Now, if we are talking about the data, what kind of data actually we use in a programming language? So particularly in C, we are using the data like integer, the numbers 1, 2, 3, 4, 5, the floats which holds the number with a decimal value, that means 1.56, 1.66. So these are the floating values. So integer and floats mostly used for the mathematical and calculations stuff, where we move to the English type instruction or words, we use the characters. So characters, which includes all the alphanumeric characters, including ABCD, 1, 2, 3, 4, all the special characters, so including the space. So characters, integers, floating. Okay. Apart from that, we also use some specific data types. So if we understand what are the types of data type, so basically the whole data type derived into 4 types. The basic data type means which are inbuilt in the system, okay, and we are using those. So basic data type, or the compiler understand these are the data types we are looking for. Then derived data type. So from the basic data type, we combined and we create a data type called derived data type. Okay, then we have data type which are enum data type and void. Void means blank or empty data type. In some cases, we have also another kind of data type. Okay, so like we get here we discuss about basic derived data type, empty data type, and enum data type. Some cases in storage classes we also use some other kind of data type, but mostly these 4 data types are used. Okay, now if we discuss about the primary data type, it is integer, character, double, and float. Okay, so as I mentioned, integer mostly hosts the integer values, character, the string values, ABCD, all those stuff it holds. But when the character combine, it is called the string, and it is single alphanumeric value, which is A or B or C, we call that a character. Similarly, float values are holding the integers with the decimal values, and double is also increment of the integer or size. Now, apart from that, we also enhance the memory size of that particular integer or character. Like, as I mentioned, data types are the uh, containers where we hold the data. Now, if your data is more or it's bigger in size, right? So we need to increase that data type size also, which are called the modifier. Now, if it is less, we can also reduce that. That's how we have four modifiers: long, short, sign, unsigned. Now, long sort to increase or decrease the primary data types, whereas signed, unsigned to define the negative and positive or the signs of the data type. Okay. Now, these are the primary data type. We'll focus on the primary data type first, then we'll move to the derived data type. In derived data type, we have array, pointers, structure, union. Okay. Then we have, as I mentioned, in some cases, we use a fifth kind of data type, which you call the Boolean data type. So Boolean means either true or false. So either 0 or 1. So Boolean data type. Okay. Sometimes we use the null data type like void. So when we'll go to write the new program in main, we can write a void. So void. So from the definition perspective, we know what are the data types. Like, as I mentioned, we have integer, we have float, we have character, then we have modifiers, sign, unsigned modifiers. But how this system understand that, okay, how much memory we need to allocate for this data type? We need to specify that particular data type with a specifier, right? So we are instructing the system to allocate this amount of memory to this kind of data type. So let's consider the character data type. So unsigned CHAR. So the minimal range would be 0 to 255. Okay. So unsigned means it is always into positive end. So 0 or more. So 0 to 255. Size of size of that memory is 8 bits. Okay. One bit is either 0 or 1. Okay, so 8 bits are linked to the unsigned character. Similarly, we are instructing by %c. So in our input instruction, we are defining a specifier %c to instruct to the system that allocate the memory of 0 to 255 of range of 8 bit. Right. Similarly, we have integer. You can see %d, %i, and this is of 16 to 32 bits. Okay, so this specifier are useful to instruct to the system how much memory they need to allocate. Okay. Now, the data type with modifier in C, as I already discussed, we have modifiers to define the sign, unsigned. Similarly, we have long and short. Okay, when we are using the long, short, sign, unsigned, the specifier also get changed, and the value or the range also change, and the size. Okay, we need to memorize this, and with the practice you automatically know how to use these specifiers at the input instructions. Okay, so those are the data types. Now we define the type of container, but did not define the name of the container. Okay, so in that case we need to define a variable. Okay, like the variable is kind of a name where the memory allocation is allocated. Let it be, I put a 8-bit memory allocated, okay, by using integer. Now that memory allocation need a name. Okay, so that name is called variable. So this variable is holding the data, okay, for operations like operations, addition, subtractions. So those operations need the variables, so we need to define the variables. How to define the variables? Simple. We need to put the data type name, then the variable, and then semicolon. It means we define the variable. Okay, and this A is the variable which stores the values. Values means the actual value. Okay, so it means you can understand like you went for a shopping and you have different containers. Like for milk, you have a different containers like a bottle. For fruits, you have a different container like you have a plastic bag. Okay, now, so that bottle, you need to give a name. Okay, you can say it's a 1 liter bottle. So 1 liter is defining the memory allocated for that or the size allocated to that bottle. Okay, and so I'm just giving that example that when you are going for a shopping, you need to shop different things, and for each of those stuff you need different containers. Like if you want milk, you need a bottle. Okay, and that bottle, you define what is the size of that bottle. Let it be 1 liter bottle. Then you need to define the material. Okay, like it's a glass bottle. Okay, so you can define 1 liter glass bottle in which you can hold 1 liter of milk when you are shopping. Similarly, if you buy the fruits, you need to put them into plastic container. Okay, so similarly, those stuff we are how analogy to this C programming, like in C also, when we are defining a particular variable uh, with a data type, we are defining the variable which kind of data it is able to store. Let it be able to store integer, so we need to define integer A. If it able to store float, we need to define float. Okay, so that's how we are defining. Now, the variables we define, again, those variables are defined in a different priority. Like we can define local variables. That means that variable can be used in that particular program. We can define global variables. That variable can use across the program anywhere. Okay, static variables. We define a static variables means we are applying a constant value to that particular variables. Automatic variables, we are creating the variables which is getting the value during the execution. External variables, which we call from a different program, or we are importing from file or from other locations, external variables. Okay, so these kind of variables we can define in a C program. We'll see in our programming how we are doing that. Okay, you can see within a function we are using a variable, so that's a local variable. So outside of the function, we are defining a variable which we can use anywhere in the program. That's a global variable for that program. Static variables, we just put a code or a keyword static int y equals to 10. It becomes static variables. But let's understand, even if we are putting a equals to 10 or x equals to 10, which is a local variable, why we need a static variable? So the static variables are the initialized only once. That means the compiler persists with the variable till the end of the program with the same initialized value. Okay, static variables can be defined inside or outside of the function. They are local to the block of that local function, and default value of static variable is 0. Okay, that means if you put static int y, the default it will take as 0. If you define 10, it will be initialized to that value. A variable that is declared with the static keyword is called static variable. Simple. Now, if I define int x, it's a general variable. If I define static int x, it's a static variable. Okay. So that's a basic difference. It initializes once, it initializes default as 0, whereas local variables we define. Automatic variables, all variables in C that are declared inside the block are automatic variable by default. Like if I define int x, it's a local variable. Auto int y equals to 20, it's automatic variables by using the character or the keyword as auto. Okay, so that's how the variables are defined. Then we are moving to defining the constant. Constant is like we are defining a value like pi value. Pi value is, we know it's 3.141 or 14. So we define const. Const means that value always hold 3.14. So const float pi equals 3.14. That means it's always constant as 3.14, right? So we understand the automatic variable with the static variable and the constant variables, how we define and how we can allocate the values. Now, we understand how to store the values in a variable. We understand how to define the variable by using the data type or the basic data type. Now, once we hold the value in the variable, we need to operate. We need to go for the operations. To do the operations, we need some operators. Without operators, we can't do any kind of operations. So C compiler also provide different kind of operators. So you can see here arithmetic operator, relational operator, logical operator, bitwise operator, tertiary operator, assignment operator, and miscellaneous operator. So there are different kind of operators in C. So from the name itself, you can understand the arithmetic operator mostly used for the mathematical operations, which includes addition, subtraction, multiplication, division. Then we have operators just to get the reminders. Then increment or decrement operators like plus plus minus minus. If we put a plus plus, that means equals to 11 means it will increase by 1 in the next execution. So that's how we are using all these operators, arithmetic operators. We have relational operators to compare between two values. Okay, so it holds equal operator, greater than operator, less than operator, not equal to operator, greater than or equal to operator, less than or equal to operator. So these are the relational operator. We have a logical operator as well. Now, the logical operator returns the value either 0 or 1, depending upon whether expression results true or false. Okay, so very kind of a binary in nature. Bitwise operator. Okay, during the computation, mathematical operation like addition, subtraction, divisions are converted into bit level. So we can use the bitwise operators to process faster. Okay. Then we have a assignment operators like equals to, plus equals to, minus equals to. So those are assignment operators. So what exactly we're looking for? Most common assignment operator is equals to. Then tertiary operator. So where we using multiple operands. Okay, so in that case, we are using tertiary operators like in expression. If expression 1 or expression 2 and with a condition with a expression, like there are three operators, three operands. So in that case, the first expression condition evaluate the first operations, then the expression 2 evaluate the second, and it will move for the third one. So like the expression 1, either it's true, then expression 2 false, then how it will move on. So like that. So condition with expression 1 and expression 2, it will proceed with a third kind of a operation, and that's how it is called tertiary operation or operator. Miscellaneous operators like your comma, size of, asterisk, which is mostly used for the pointer, means that memory location we need to find out. Condition expression, if condition true or false. So those are called miscellaneous operators. Now you understand the operators. Now we need to understand what are the priority of that operators. If multiple operators are used in one go, how the compiler take the priorities, very similar to our mathematics concepts, right? So you can see here the operators priorities mostly for the postfix, like left to right, for unary, like right to left, for uh, multiplicative, it will be left to right again. So mostly it is left to right, left to right. Only the unary is right to left. Okay. Similarly, in case of a bitwise operator, it is also left to right, left to right. Only one, conditional and assignment, these two are right to left. Other operations are having left to right. So when there are multiple operators are used in a same line. So let's write some program and check how the operators are functioning. Okay, so let's go to the compiler again. So we discuss about the data type. Let's, in the same program, we define some data type first. So let's define int a and b and c. Okay. Now, when we define a, b, c, we need to get the input value for that. Okay, so what would be the input value for that? And we need to use the input of function, which is scanf. Okay, so scanf. So then what exactly we need to define? Which kind of value we need to looking for? Okay, so we are looking for a. So a is integer. So what would be the specifier? Specifier would be %d. Similarly, one more %d. And to allocate the values, we need to use ampersand. Okay, ampersand a, comma, ampersand b. That means these two values need to be allocated at the memory. Okay, so in the top, I can put a printf and asks to enter the values. Please enter the values for addition. Okay. Okay. Finally, I need that output. Okay. So the output would be at C, but before that we need to use the operators. So C is equals to A. I'm using here addition operator, B, and end of that operation. Printf, the addition now here we can know C is the addition of two programs. So how we'll see diff C, but it would be output as %d, right? Now %d first we need to call, and then we need to define C. Let's see what kind of error we can get. Okay, then let's save this. So it is asking, you can say, oh, it's an old one. First, let's do we save this, save. Now it is saved, then execute. Oh, it is not yet saved. Okay, so it is giving errors. You can see int. So here I missed a semicolon. Let's check again. Any error? Yes, another error. So the errors will come in the below. You can see expected before C. Okay. So I missed a comma when I declare C. So that's how it is throwing again another error. Let's see one more error. So here again, I did not define anything, comma, then execute. Okay, now it is get executed. Enter the value for addition. Let's enter 5 and 6. So it is showing the output as 11, right? Now when I went inside the system, it is showing in the same line. Okay, can we make it to next line? Okay, so how to put the next line? It is /n. Okay, let's see how it will work. Okay, so we can see it is asking to please enter the value addition for addition. In the next line, it is showing to enter the value 6 and 7. And the value is coming as 13. Any queries till now? So this is the program where we first use the scanf, we use the operators, and we executed them by using the operations. Okay, and we also allocate the memory for integers. Okay. So you can practice as much as programs you can by using multiple operands, multiple types of data types, multiple operators. And let's proceed to the next section, which is called decision making in C. Mostly it is called loops. So how the loops are used in C, that would be our next session. Okay, so thanks for your time.
Guys, if you are liking our channel, if you are thinking that we are putting good efforts to make good contents over here, then please do like, subscribe, share, and press the bell icon below. Thank you.